terms which we are going to use. The polar modulus of a section. Okay, now we have studied section modulus. Everybody knows what is a section modulus? Yes? Yes or no? Hello?
Yes, sir.
Now I'll be calling out some of the names today because people are sleeping. Okay, so section modulus. Now what do you mean by section modulus? And that we already know. Now what is the polar modulus? Or basically we are going to understand the polar moment of inertia. The polar moment of inertia. Now, if you remember the moment of inertia when we are studying, we have studied two theorems. One is perpendicular axis theorem and parallel axis theorem. But we have been using parallel axis theorem so widely in the last two chapters, to shift we call it as shifting axis theorem, right? So now polar moment of inertia based on perpendicular axis theorem. For example, let's say I have a circular section. Let's say I have a circular cross section. Okay. Sorry. I have a circular cross section. Now this is the centroid of circle. Let us assume that this is x-axis. Let us assume that this is y-axis. Okay. So if your cross section is circle and if it is having diameter d, this is the cross section, it is having diameter d. So what is your moment of inertia about x-axis? Can you tell me? The formula is pi by 64 d raised to 4, right? Everybody, we have studied this formula. So now if you want to find out moment of inertia about y axis, so it will also be pi by 64 d raised to 4. But if someone asks you to find out the moment of inertia about an axis perpendicular to this plane, axis perpendicular to the plane of this, about z axis. So if you want to find out IZZ, then we know the perpendicular axis theorem that IZZ will be equal to IXX plus IYY, right? Moment of inertia about two mutually perpendicular axes which are in the plane of the body. So therefore, if I add this, my pi by 64 d raised to 4 plus pi by 64 d raised to 4 will give me pi by 32 d raised to 4, right? Now this is my moment of inertia. This can also be called as polar moment of inertia, and the polar moment of inertia is denoted by J, letter J. Okay, so J for circular cross section is pi by 32 d raised to 4. Pi by 32 d raised to 4. Understanding it? Now this is called as polar moment of inertia of this. Now what is polar modulus? Now what is polar modulus? What was section modulus? If you remember, the section modulus was, it is, anybody can tell me what is section modulus?
I by y.
I by y. What is y in that case?
Y max the distance of.
Maximum distance of the layer, right?
Yes.
Okay. The similar way, यहाँ पे in cross section, if the cross section is circular, what is the y distance? Wait a minute. हाँ, yes. बताने वाला था कोई तो y का distance क्या होता है? I'll try with this. I can have it. Yes, yes. Tell me, what is the y distance in case of y, in case of circular cross section? Hello. Hello. Hello.
Yes, sir. Yes, sir.
Yes, sir. Yes, sir.
सर आवाज नहीं आ रहा है।
No, sir, you're not audible.
Not audible, sir. Not audible.
My earphone doesn't work. Okay. Tell me. Okay, now is it audible, right?
Yes, sir. Yes.
Yes, sir.
Yeah, sir.
Tell me what is the distance y. Now section modulus जैसे हमने find किया था, similar way में I can find out the modulus. ठीक है, but this time I will not be using only moment of inertia about neutral axis. I will be taking polar moment of inertia, right? So if I talk about polar moment of inertia J divided by the maximum distance y, but here in this case most of the times we will have circular section, so we can take J by y or J by r, because your y is nothing but what? Y maximum is nothing but
Radius of the circle.
radius of the circle, right? R. So if I take the polar moment of inertia upon this R, that is nothing but y maximum, will be called as what? The polar moment, polar modulus. Polar modulus of polar modulus of a section. Okay. मतलब circular section के लिए. Now, what will be the polar modulus of the section in case of circle? Now we know the J value. The J is pi by 32, so therefore it will be pi by 32 d raised to 4 है, and यहाँ पे वो R है, but R can be written as what? This R is nothing but d by 2 ना, एक d यहाँ पे cancel हो जाएगा, ये 2 ऊपर जाएगा, तो it will be pi by 16 dq. Is it correct? Have you understood this?
Yes, sir.
The J by R value for circular cross section will be pi by 16 d raised to q. Okay. Now similarly, if I have another cross section, but this time it is a hollow circular cross section. We have a hollow circular cross section such that the smaller diameter is small d and the bigger diameter is capital D. Now can you tell me what is the polar moment of inertia and polar modulus? Yes? Anyone can try? What
Sir,
will-
तो outer diameter वाले circle का minus inner diameter वाले circle.
Okay, so polar modulus will be pi by 32. It will be capital D raised to 4 minus small d raised to 4, right?
Small d.
What will be the modulus? Polar modulus. We can call this polar modulus as ZP also, polar. Because if you know section modulus, we were calling it as Z. So we can call it as ZP, Z polar. Okay, what will be Z polar for this case? Yes.
Capital J upon capital D.
Capital J upon capital D by 2. Radius ना? Understanding it. Neutral axis ना हमारा ऐसा होता है.
Radius.
तो
हाँ,
ये
D by 2.
है हमारा y maximum. And here it is equal to capital D by 2. तो यहाँ पे अगर मैं substitute करता हूँ तो it will be pi by 32 upon D by 2. तो यहाँ पे D नहीं cancel हो सकता. 2 cancel होगा only. So pi by 16 and we will get d raised to 4 minus small d raised to 4 upon capital D. Are you understanding it? तो हर बार वो directly इसके terms में नहीं आएगा. You have to think on and how to get it. Okay, have you understood what is polar modulus and what is
Yes,
the
sir.
polar
Yes,
moment?
sir.
Yes,
Now,
sir.
can you tell me how to calculate polar moment of inertia for a minute. Polar moment of inertia okay. Polar moment of inertia for rectangular section. Let us now go for a rectangular section. Okay, so we have a rectangular section where this is depth D and this is breadth B. Okay, now tell me what will be the polar moment of inertia for this. polar moment of inertia is nothing but we can call it as either IZZ or it is same as J. तो क्या होता है? It is IXX plus IYY, right? If I say this is my XX axis and if I say this is my YY axis, then what is moment of inertia about XX axis? It will be BD cube by 12, right? And about YY axis it will be DB cube by 12.
DB cube by 12.
Add it, you will get BD cube plus DB cube divided by 12. This is your polar moment of inertia J for rectangular section. So similar way you can find out for any of the cross section. You should just know that the polar moment of inertia is the summation of IXX plus IY for any of the cross section. Now how to do these inertia we have already done that. Okay. Now without wasting time, let us go for torsion. Okay. Let us go for theory of pure torsion. So that is the next part which we have. Now to understand twisting moment. Now we know that what do you mean by torque? Can anybody tell me what is torque? Now, you have been studying so much in physics and as well as in mechanics, engineering mechanics, you must have studied about couple and torque. So what is torque? Yes. Till that I draw a diagram, you can answer.
Equal magnitude of force acting in opposite direction.
Okay. What it causes?
Sir, rotation.
Object to move around its axis, rotate around its axis.
Rotate around a
Axis.
okay. Fine. Anyone else would like to add something to this? No one? Okay, let us assume that same definition. This is nothing but torque is nothing but rotary effect. Okay, anything we want to rotate, we apply torque. Okay. Yeah. Now let us assume that you can see there is a shaft. I have a shaft or a bar which is having a rectangular cross section. It's the rectangular, circular cross section, and the circular cross section is of radius r. The radius है, तो radius है उसका r. Let us say there is a point A and O is the center and the radius is capital R. Okay, there is a shaft. Now ये shaft इसका center यहाँ पे होगा and इसको अगर इसको मैं join करूँ center to center तो ऐसे axis है. This is the axis, right ना? This is the axis. Now what I am doing, I am applying a torque on this particular shaft. What I am doing is I am applying a torque. Now this torque will try to twist this particular rod in this direction. Okay. What I have applied is T, which is torque. Getting it? सबको समझा? Torque apply किया मैंने. मेरा मतलब I have a particular let's say a shaft and I am twisting it by fixing the other end. Other end is fixed and I am just twisting it by applying a torque. Okay. So what will happen? Yes, what will happen? If I apply the torque, the free end will try to displace. This particular section will rotate as compared to this. मतलब क्या देखो दो section assume करता हूँ मैं. ये section fixed है और ये section पे torque apply किया मैंने. तो क्या होगा? Because of this section is fixed, it is not going to rotate, but this section will rotate. पहले जो उनका alignment ऐसे रहेगा, तो अभी ये दूसरे का alignment ऐसे change हो जाएगा. Do you agree, all of you?
Distort हो जाएगा.
Yes, sir.
हाँ, distort होगा.
Yes.
और उसका displacement ऐसा change हो जाएगा, right ना? तो पॉइंट ए का जो पोजीशन इधर है, अभी पॉइंट ए का पोजीशन क्या हो जाएगा? चेंज हो जाएगा. जो डायरेक्शन में रोटेट कर रहे हो वो डायरेक्शन में. यस और नो?
Yes.
तो देखो अभी मैं पॉइंट ए का पोजीशन लेट्स से यहाँ पे आ गया. इधर आ गया, इधर आ गया. एंड नाउ हाउ मच इज दिस डिस्प्लेसमेंट? आई हैव अज्यूम्ड इट इज लेट्स से थीटा. ओके, लेट अस अज्यूम दैट दिस इज ए डैश. दिस इज ए डैश. या फिर ए डैश के बदले बी ले लेते हैं बिकॉज इजी हो जाएगा. बी तक गया. ए पॉइंट इज नाउ ट्रैवल्ड अप टू बी. तो ये आर, ये है इसका डिस्प्लेसमेंट. ओके. नाउ तो ये अभी ये खाली आर्क नहीं डिस्प्लेस होता, राइट? पूरा मटेरियल क्या होगा? सरफेस जो है वो ट्विस्ट होगा. सो दैट मीन्स पहले अगर मैं यहाँ का और यहाँ पे पॉइंट ले लेता तो अगर ये पॉइंट तो यहाँ पे फिक्स्ड ही है जो ए के पैरेलल में था, राइट? बट अभी क्या हो गया? ए वहां पे चला गया तो जो लेंथ ऐसा था, जो लीनियर फाइबर्स थे मटेरियल के, वो जो स्ट्रेट थे अभी वो क्या हो गए, ट्विस्ट होके इधर आ गए. इज इट नॉट? बराबर. तो इनके बीच में भी कुछ एंगल हुआ है यहाँ पे. नाउ दिस, let's say call it as phi. Now this phi will represent shear strain. Shape change हुआ ना ये सबका? Yes or no?
Yes.
What is shear strain? If you remember in the first chapter we studied what is shear strain or shear stress. क्या होता है? Anybody?
Change in length upon original length.
I'm not asking strain. I'm asking you shear strain.
tan theta x by
Tan theta या tan phi, but होता क्या है वो? Phi क्या है? When one upper surface displaces with respect to lower surface. तो अभी यहाँ पे क्या हो रहा है? एक cross section is rotating with respect to the fixed cross section, and there is a certain distance between them. Let us assume that ये जो पूरा rod है उसका length कितना है? So we are assuming the rod is of length, let's say L. So let us assume some parameters which we have used here. T is the torque applied, right? R is the radius of shaft or bar. It can be radius of shaft or bar. Then yeah, L is the length of this shaft. Let us assume that G, capital G. What does capital G stand for? Yes.
मॉड्यूलस ऑफ रिजिडिटी.
Yes.
सर इसके अंदर एक्चुअली एक डाउट था, जो हम फाई कंसिडर कर रहे हैं दैट इज वेरी फॉर अ वेरी स्मॉल एंगल, राइट?
Yes.
सर अगर किसी कंडीशन में अगर हमें फाई लेना है तो हम इसमें सेक्टर लेंथ बेटर नहीं रहेगा? मतलब जो सेक्टर लेंथ कवर होता है, द येलो पार्ट दैट यू हैव डन, दैट इज अ मोर एक्यूरेट अजम्पशन कि कितना डिस्टेंस ट्रेवल हुआ है rather than थीटा फॉर बिगर.
सेम ही तो है उनका प्रोजेक्ट. मल्टीप्लाई बाय रेडियस करेंगे तो इट विल बी सेम थिंग, राइट?
बट सर इन अ 3D फॉर्मेट, मतलब अगर इसको मैं एक्चुअली मुझे हल्का सा कंफ्यूजन था इसके अंदर कि अगर हम इसे 3D में कंसीडर कर रहे हैं.
I'm coming to that particular point. Wait a minute.
ओके.
In that derivation, just give me 1 minute. So G is the modulus of rigidity of the shaft. I'm coming to this point where A and B is the arc which is displaced, right? Now you can see AB arc is common for both these sectors. मतलब AOB sector लो या फिर अगर if I take this point as A, ACB sector लो, C point लिया मैंने, तो उनके लिए AB common है. Now this arc AB can be written as R into theta, where theta is in radian, right? As well as arc AB, अगर मैं ये longer sector लेता हूँ जिसका radius I can assume at length of the shaft, so I can say this is L into phi, where phi is also in radians. So from these two relations, what I can write down the relation between them as the relation between these two points as R theta or else L into phi can be given by R into theta, and then your phi, the shear strain, is R theta by L. Shear strain, right? Now this phi represents your shear strain. Now what is shear stress? So we know the G. What is modulus of rigidity? It is shear stress tau upon shear strain phi. This is the basic formula which I studied in the chapter 1 only, right? So here tau is shear stress in that particular layer जो हमने assume किया. तो your shear stress tau can be given by G into phi. So your G into phi का value तो हमें पता है R theta by L. So your tau, so अगर मैं ये tau by R लिखता हूँ तो मुझे क्या मिलेगा? It will be G theta by L. ठीक है? Let us say this is my equation 1. Let us assume that this is equation 1. Okay, this is equation 1. So tau by r is equal to g theta by L, and that is equation number 1. Okay, so what we have understood up till now is the shear stress. Okay, shear stress is proportional to no, g is a constant for a given material. Theta अगर मैं एक particular ये देता हूँ तो theta is the angle of twist, जो twist हो रहा है मतलब, right? So if that for a given angle of twist, my shear stress will be proportional to radius. You can see here r. अभी r मैंने outermost radius लिया है, ठीक है? But ये पूरे cross section में खाली outer में surface नहीं है ना. अगर मैं ये cross section को horizontal way में draw करता हूँ, तो see here ऐसा मतलब if I take the cross sectional view like this. Okay, so this is my central point, center O. अभी मेरा जो पॉइंट ए है वो यहाँ पे था एंड वो ट्विस्ट होके इधर गया बी पे. तो जो भी हमने शेयर स्ट्रेस अभी फाइंड किया वो यहाँ पे ये वाले लेयर पे फाइंड किया. बट देयर आर एन नंबर ऑफ लेयर्स इनवाइड. ऐसे अंदर आते आते कितने बहुत सारे लेयर्स है. हर लेयर में शेयर स्ट्रेस अलग अलग आएगा बिकॉज उसका डिस्टेंस फ्रॉम सेंटर विल बी डिपेंडिंग ऑन दिस आर, विल नॉट बी मैक्सिमम वैल्यू ऑफ आर. आर यू अंडरस्टैंडिंग माय पॉइंट? तो यहाँ पे हमें पता चलता है कि वेरिएशन ऑफ शेयर स्ट्रेस कैसे होने वाला है. द वेरिएशन ऑफ शेयर स्ट्रेस विल बी unlike your bending and shear, the bending and shear due to transverse loading, it will be maximum. The shear stress is going to be maximum on the outermost fiber. It is going to be tau maximum on the outermost. It will be 0 at the center, and again it will be maximum on this side, tau maximum, and both sides it is positive. So the shear stress distribution due to torsion will be like this. Are you understanding it? The variation. Have you understood why this happens? Because your tau, if I take it is g theta by L, तो ये constant है. It is depending on this r. So as your r varies, r maximum है तो tau maximum, r minimum है तो tau 0 होगा. r का value 0 है यहाँ पे center पे, तो shear stress is 0, right? So this is the variation of shear stress with respect to the cross section or the distance r. Now let us understand the relation between torque what we applied. Okay, so again I am drawing the same kind of this one. So now let us consider sorry. Okay, so we have a cross section. Now consider an elemental strip. एक elemental strip consider करते हैं यहाँ पे at any distance r, small r. क्या कर रहे हैं हम लोग? एक elemental strip assume कर रहे हैं. Let's say here like this. This is the elemental strip जो hatch करके रख रहा हूँ मैं. ठीक है, which is at a distance of small r and जिसका thickness कितना है? dr है. Getting it? Elemental strip. अभी ये elemental strip को अगर straight करके ऐसे बढ़ा किया straight, तो ये elemental strip का area कितना हो जाएगा? Can you tell me? ये उसका length हो जाएगा. अगर कट करके सीधा किया तो it will be 2 pi r, right? तो r उसका radius है तो circumference कितना हो रहेगा? And उसका thickness कितना assume किया है हमने? dr. So what is this area? Small area dA. That will be 2 pi r into dr. Are you understanding it? Area समझ में आया? अभी मुझे बताओ, यहाँ पे कहीं कुछ ना कुछ तो shear stress value रहेगा. जब मैं इसके ऊपर ये particular cross section के ऊपर torque apply करने वाला हूँ. For example, I have whatever the torque I have applied. Let's say this is the torque which I have applied. Sorry. This is the torque which you have applied. So because of this torque, there will be shear stress on this every layer. यहाँ पे भी shear stress होगा. Tau tangential shear stress होता है ना. Shear stress is always tangential. If you remember, तुमको अगर पता है shear stress tangential होता है, तो shear stress ऐसे act करेगा वो layer पे. ठीक है? तो shear stress multiply by area will give me the force, and that force मतलब अभी ये particular जो area मैंने assume किया hatched area, वो कितना torque produce करता है और वो कितना torque में contribute करता है वो हमें find करना है. So let us understand, let us write down. Let us consider a small elemental strip at radius r as shown in figure. ये मैंने लिख कर दिया, right? Now the torque transmitted by this elemental strip कितना होगा? तो very small amount of torque dt लिखते हैं, वो क्या होगा? टॉर्क क्या होता है? टॉर्क होता है फोर्स मल्टीप्लाई बाय रेडियस, इज इट नॉट? टॉर्क इज फोर्स मल्टीप्लाई बाय रेडियस, ये सिंपल फॉर्मूला सबको पता है. सो व्हाट इज फोर्स? तो हमको फोर्स पता नहीं है, तो फोर्स क्या है? शियर स्ट्रेस मल्टीप्लाई बाय स्मॉल एरिया डीए इनटू रेडियस, तो आर है, वो स्ट्रिप का रेडियस तो आर है. तो अब ये टाउ का वैल्यू भी हमें पता है, सो लेट अस सब्स्टिट्यूट. Sorry, area का value हमें पता है, let us substitute that. So what is the small amount of torque which is transmitted? I'm going to the next slide because I don't have the time. So the very small amount of torque dt can be given by tau into area, small area into radius. Now tau as it is, what is your small area? It is 2 pi r into dr into this r again. So that is equal to your small amount of torque. So therefore my small amount of torque will be equal to tau into 2 pi r square dr, राइट? तो ये हो गया एलिमेंटल एरिया, बट पूरा क्रॉस सेक्शन कितना टॉर्क ट्रांसमिट कर रहा है तो वो भी हम लोग कैलकुलेट कर सकते हैं. सो देयरफॉर द टोटल टॉर्क ट्रांसमिटेड बाय कंप्लीट क्रॉस सेक्शन और एंटायर क्रॉस सेक्शन what will be that? It will be total torque. You have to integrate this dt, but कहाँ से कहाँ पे? From 0 to radius capital R, because my shaft जो मैंने assume किया है उसका cross section 0 to capital R है. So now let us integrate this. So let us integrate 0 to capital R. What is the formula? Tau into 2 pi r square dr. अभी देखो for a given section shear stress, जो shear stress का value है, what will be the yeah, now the shear stress is going to be vary, but I don't know how to vary the shear stress for a given angle of twist. So let us understand now. We know that, but from equation 1 what we have written? Equation 1 में we have written tau by r is equal to g theta by l. But if you say, मैं अगर बोल रहा हूँ कि for a given angle of twist, g theta by l is a constant. G is constant, length of the rod is constant, theta is given constant है. So if I say this is constant, then this tau by r can be written as shear stress. Now देखो tau by r लिखूंगा तो ये tau maximum होगा जब मेरा r maximum होगा. Tau का any value and any radius. Are you understanding my point? मतलब क्या, ये मेरा जो cross section है तो maximum value कहाँ पे आने वाला है? Maximum value तो outermost surface पे आने वाला है इधर. ठीक है, जैसे जैसे मैं अंदर जाऊंगा, जैसे जैसे मेरा रेडियस कम होते जाएगा, ठीक है, आर कम होते जाएगा, मेरा शियर स्ट्रेस का भी वैल्यू क्या होगा? कम होते जाएगा. सो दिस इज गोइंग टू बी कांस्टेंट. फॉर मैक्सिमम शियर स्ट्रेस यू हैव टू टेक मैक्सिमम रेडियस. फॉर एनी वैल्यू ऑफ शियर स्ट्रेस एट एनी लोकेशन यू हैव टू टेक दैट रेडियस. सो दिस इज द रिलेशन, राइट? बट यहाँ पे क्या पता चलता है हमें कि दिस टाउ बाय आर इज अ कांस्टेंट. ये तो कांस्टेंट है ना, जी थीटा बाय एल सेटिस्फाई करना चाहिए ना इक्वेशन 1 के हिसाब से. तो आई नो दैट कि टाउ बाय आर कांस्टेंट है, राइट? टाउ बाय आर क्या है? कांस्टेंट है. एंड वो हमें क्या करना है यहाँ पे? यूज करना है. ठीक है, वेट अ मिनट. या सो नाउ सी हियर, therefore what we can do here, जो हम लोग टॉर्क अभी फाइंड कर रहे हैं, टॉर्क इक्वल टू 0 टू कैपिटल आर. ये टाउ जो है वो अगर उसको मैं मैक्सिमम अज्यूम करता हूँ, ठीक है, I can write down that tau maximum also. तो tau मैं एक r डिवाइड कर लेता हूँ because that is constant which I can keep it outside the this one. देखो tau by r because I know that कि tau by r is constant. बराबर ना. सो टाउ बाय आर लिखा मैंने, एक आर एक्स्ट्रा लिया तो मैं ये क्या करूंगा 2 पाई आर क्यूब कर दूंगा अभी, राइट. 2 पाई आर क्यूब कर दूंगा डी आर. नाउ सी हियर दिस इज कांस्टेंट, एक साथ उसको बाहर लिख सकता हूं बिकॉज़ इट्स अ कांस्टेंट एंड 2 पाई इज कांस्टेंट. सो लेट अस टेक इट आउटसाइड. So 2 pi tau by r is a constant. What I am getting is 0 to capital R, r cube dr. R cube dr. 0 to capital R, r cube dr. Now what is the integration of r cube?
R4 by
R raised to 4. So therefore what I am getting here is 2 pi tau by r into r raised to 4 from 0 to capital R. So 2 pi tau r raised to 4 minus 0 raised to 4. 0 raised to 4 is 0. So we will get this as 2 pi tau by r into r raised to 4.
Sir,
That is
r raised to 4 upon 4.
Yes. R raised to 4 by 4. So here there will be 4. Now here there will be 4. Now see here, what is the torque I am getting? What is the torque I am getting? 2 pi tau by r into capital R raised to 4 है ना. ठीक है, अभी क्या करते हैं, कैपिटल R को मैं लिखता हूँ डायमीटर बाय 4, तो डायमीटर बाय 2, तो डायमीटर बाय 2 रेज़ टू 4 by 4, बराबर. तो ये क्या हो जाएगा 2 pi tau by r into, ये हो जाएगा डायमीटर रेज़ टू 4, 2 रेज़ टू 4 कितना होता है 16 4 जा 64 बराबर. एक 2 कैंसिल हो जाएगा तो कितना 32. सो व्हाट आई एम गेटिंग, देखो पाई ये 32 इसके साथ लिखता हूँ, पाई बाय 32 डी रेज़ टू 4 इनटू टाउ बाय आर चलेगा. बट व्हाट इज पाई बाय 32 इनटू डी रेज़ टू 4? फॉर अ सर्कुलर सेक्शन इट इज पोलर मोमेंट ऑफ इनर्शिया, राइट ना. For a circular cross section it is polar moment of inertia. So therefore I am getting some relation here. Okay, so therefore torque by J, polar moment of inertia, is tau by R. Let's say equation 2. And therefore from 1 and 2, what I can write down? Tau by R is equal to T by J is equal to G theta by L. This is called as equation of torsion or torsion equation. Now if you see, this equation is exactly analogous with the flexural equation or the bending equation we have studied. What was bending equation we have studied? Can anybody tell me? Yes. What was bending equation we have studied?
M by I equal to E by R equal to sigma by Y.
मैं अभी थोड़ा ये लिखता हूँ, sigma by y is equal to m by I is equal to E by R, right? बराबर ना? So is there any correlation between these two equations? Yes or no? What was sigma? Bending stress. What was y? The maximum layer at which the bending stress you are calculating. See here, tau is the shear stress. What is R? The layer at which you want to find out the shear stress. What is T? Torque. Here M, moment. Torque and moment are same thing, right? I is the inertia of neutral axis. J is the polar moment of inertia. Because twisting act, torsion या twisting moment जो देते हैं हम torque देते हैं, वो about polar about Z axis होता है. इसके लिए हमें polar moment of inertia चाहिए. So that is the polar moment of inertia there. Then G theta by L was the material constant. Yeah, E by R is also the material constant. Understanding it? So this is how. So if you remember this equation, you can also write down this equation. Both the equation they go hand by hand. Understanding it? Yes or no?
Yes.
So everybody has understood this torsion equation. Shall I ask some of?
सर वो टाउ बाय आर नहीं समझाएगा, फिर से एक्सप्लेन करूंगा. टाउ बाय आर क्या?
What is tau by r? क्या है? Tau is what? Shear stress. ठीक है, तो मतलब अगर मुझे shear stress maximum layer पे चाहिए तो what R I'll take? The maximum radius. अगर मुझे shear stress middle layer पे चाहिए तो what I'll take? वो जो value है center से उतना लूंगा. बराबर ना? ये ऐसे ही सेम यहाँ पे हम लोग करते थे. अगर सिग्मा मैक्सिमम चाहिए तो तुम क्या लेते थे? y मैक्सिमम लेते थे. अगर सिग्मा कुछ पर्टिकुलर लेयर पे चाहिए तो क्या लेते थे तुम? डिस्टेंस ऑफ दैट लेयर फ्रॉम न्यूट्रल एक्सिस लेते थे, राइट? बराबर कि नहीं?
Yes.
Yes or no?
Yes, sir.
Similar way. अगर तुम्हें shear stress maximum चाहिए, तो you take R का maximum value, which is the radius of the shaft. And अगर तुम्हें shear stress कम अंदर के layers पे चाहिए, shear मतलब अगर मेरा let's say ये मेरा पूरा shaft है, तो पूरे shaft पे यहाँ पे जो shear stress होगा, वो maximum होगा. जैसे जैसे मैं अंदर जाऊँगा, shear stress कम होता जाएगा. Center पे जो shear stress आएगा, वो zero आएगा. Center पे जो आएगा, वो क्या रहेगा? Zero रहेगा. ठीक है? When I'm applying a torque on this, the maximum shear stress will be जो सबसे ज्यादा लेयर ट्विस्ट होगा वो ऊपर का रहेगा. Getting it?
Yes, sir.
Okay. So have you understood the variation of shear stress due to torsion?
In this module, in this module, would we be considering कि जो force है वो पूरा surface पे evenly लग रहा है या फिर at a point लग रहा है on the surface?
I'm not getting you. What is your answer question?
सर हम जो टॉर्क लगा रहे हैं बॉडी पे, वो हम हर मतलब पूरा बॉडी पे इक्वल टॉर्क लगा रहे हैं या फिर एट अ पॉइंट लगा रहे हैं?
एट द एंड लगाया मैंने. वो कहाँ पे लगता है उसके हिसाब से एल डिसाइड होगा. देखो
मतलब सर ओवरऑल सर्कमफ्रेंस पे वो इक्वल लगेगा ना?
हाँ दैट इज ऑफ कोर्स.
हाँ.
पूरा सर्कमफ्रेंस को रोटेट करने का ट्राई कर रहे हैं ना. रोटेशन इज अबाउट दिस एक्सिस. तो इसका मतलब है कि लीनियर डिस्प्लेसमेंट, द एंगुलर डिस्प्लेसमेंट ऑफ द एंटायर क्रॉस सेक्शन विल बी सेम, बट नॉट द लीनियर. इसका रेडियस ज्यादा, उसका लीनियर डिस्प्लेसमेंट ज्यादा होता है. सर्कुलर मोशन यू हैव स्टडीड, राइट?
सर आई वाज जस्ट मतलब अज्यूमिंग जो एक कंडीशन रहती है ना कि शाफ्ट कनेक्टेड है सपोज दोनों एंड से, एंड एक शाफ्ट जो है वो स्टेडी होल्डेड है.
दैट इज द नेक्स्ट पार्ट व्हिच यू आर गोइंग टू स्टडी. वेट, वी हैव कनेक्टेड शाफ्ट, पैरेलल शाफ्ट, सीरीज शाफ्ट, so many things we'll do. Don't worry, I'll go slow by slow. Have you understood this part?
Yes sir.
Okay, so now we can also write down. Let us now understand there are some assumptions we have made in this particular deriving this particular theory or understanding this particular theory. So what are those assumptions?